Welcome to the Persistency as a Service screencast for GigaSpaces XAP. Persistency as a Service is a reference to a mechanism by which data stored in an in-memory data grid is automatically and asynchronously mirrored to a database. A related facet is initial load, which populates an in-memory data grid from a database. The way this works is fairly simple. You have a data feeder, something that creates data. It takes these data items, whatever they may be, and puts them into a space. The space then queues up writes to a mirroring processing unit itself, which is a facade space. And that mirror then writes those changes out to a database, whether they're updates or deletes or whatever. So what you have is an asynchronous process by which data going into a space is written out to any real data store. We keep talking about a database, but that's not necessarily the case. We do provide an API for building persistent services, but Hibernate is built in, which means you can use any Hibernate toolkit to design a model for mapping to a database. However, it's important to realize you're not limited to Hibernate. You can use the external API to save and load from anything, an external object database, a CSV file, JDBC, anything you like, really. So let's step through an application that uses both mirroring to a database as well as initial load. So let's create a basic Maven OpenSpaces project. All we have to do once we have the Maven plugin installed for OpenSpaces is run a single Maven command, the os create command. Let's go ahead and take a look at what that gives us just so we can establish some context. So we have Maven os create. This will basically tell us that we're missing a template. There are 5 basic templates that we provide with GigaSpaces XAP 7.1. The one we're most interested in is the basic async persistency. So all we have to do then is create the project with a basic async persistency model, the archetype. If I can actually type, we give it a group ID of com.gigaspaces. If I can actually type, like I said, then artifact ID of PAAS3. And it'll go through and build us a project, a few seconds really. If we go into that directory, what we see is our 4 common module types are common, which is going to provide us our data model, our feeder, which generates the data for the space, the mirror, which is oddly enough the mirror service, and the processor, which actually does all the work. So what we're going to do now is hop over to Eclipse and modify these projects just a little bit, then we'll step through the pieces so we can actually run this. So now we're looking at Eclipse. We have our 4 basic modules imported in. Let's take a look at the common object first. This is our basic data model. We have only one item in here, and that's the data object. The data object is very simple. All it is basically an EJB3 annotated bean. We've got table and entity, which are fairly standard. We've got an ID. We're not even using any Hibernate attributes here. We're just using the standard JPA annotations. We do have a couple of space-based routing annotations, the space class, the space ID, and the routing information. But you really don't need these. This is just a standard Hibernate object, really. So next, let's look at the mirror itself, because that's going to be kind of where all the fun stuff happens. So the mirror is actually quite simple. All it really is a Spring configuration held here in the main resources meta-inf Spring pu.xml directory file. All it is a Spring configuration. It's literally all it is. In this case, because we're using the default Hibernate data persister, all we really have to do is define a data source. We define a session factory. The custom elements for the mirror are the data element here. We're telling it what classes it's to persist. Then the rest is very much standard Hibernate stuff. We've got a Hibernate data source here where we're tying the session factory in. Now the space configuration is a little bit different because we're telling it the external data source to use, plus we're telling it to use the mirror schema, which sets it up as a listener for updates to the space based on those classes. So whenever we write a data item, this thing up here, into the space, what'll happen is the mirror service will receive a queued update, so it'll do a bulk persist to the data store, so everything gets saved at one time safely. And if the mirror service disappears, well, it'll actually queue up those writes so you don't lose anything. Whenever the mirror comes back online, it'll go ahead and do a full update to synchronize the database to the space status. Now, a processor actually creates the data grid itself. It has a similar file in resources Spring processor unit XML is what it is, this thing right here. This looks almost exactly the same. In fact, we can copy this information almost verbatim from the mirror, the mirror processing unit. In fact, we could have put it in a common position in the common unit and then imported them both into the Spring configuration. The data source here, again, looks exactly the same. This is where all the fun stuff happens with initial load. First off, we do tell it to mirror. This will look for a mirror space out there. It'll look for the facade, and it'll then initialize. It'll initialize the connection by which it sends writes to that mirror. Here, what we're doing by setting an external data source and then setting these properties, what we're doing is we're telling it we want you to load all of the elements from the data source into the space. This is our initial load facility here. What this means is whenever the thing starts up, it's going to get the data, whatever we have in our database, on startup. It's really kind of convenient for persistent situations where you actually have the grid shut down entirely for some reason. It's important to note that normally that doesn't happen. I mean, the system is really kind of designed to be fail-safe, but if you should happen to shut everything down, this will reload everything from a clean position. Now, the last thing we look at is the feeder itself. This is, again, just a standard, in fact, we've seen this is a standard operation here. It's just a command line operation, a command line program that where we give it a number and it connects to a space and writes data into it. Really nothing spectacular here. This is almost really quite standard. I think the only change that I really made was to use the Java util logging consistently throughout the whole project. So now we have a GS agent running with 5 GSCs, 1 GSM, and 1 lookup service. This is, again, very standard for a lot of these demos. So what we're going to do is we're going to use the Maven deploy command to actually send this stuff out. So this is actually very simple. We do a directory. We've got our standard Maven modules here. We can do a Maven OS deploy. This will actually go through and make sure after our project is built, deploy the project to the space locally. So you can see what it's doing right now is it's actually uploading the mirror here. So it'll be deploying this very soon. We'll see that reflected up here on GSC3 as it turns out. So now what it's doing is it's going to the processing unit and deploying that. So let's watch as that happens. And you can see here that everything has been uploaded. We look over here, and you can find all of our elements up here. Everything's working normally. Now, if we go to the deployed processing units, we see everything is running properly. We've got our feeder. It's actually running the feeder now as well, so we should actually see data coming through. If we look at the space here, what we will see is 17 items. So we'll see it going up and up. So let's take a short break here, and then let's look at the database, because this is going to be proof that we're actually writing data out. So now we're back in Eclipse. Let's take a look at the database here. We have the test database. Let's go ahead and connect. So here's our database right here in our tables. This has actually been mirrored out, so we can take a look at the columns. Everything's standard here. It's been created by Hibernate. Let's take a look at the data. So we look over here, and what we have is just really our feeder data. We should have 31 elements. That's about right for where we stopped the process. You see that all the data, this includes events being handled, because it goes through with this data right here, and this is blank. Then the event handling system writes this item back out. So we're actually seeing the data going out once, probably without this field right here, and then going back out with this data if it happens to be a short delay between the actual synchronization. Plus, chances are all of these were written at pretty much the same time, because it can batch updates as we send extra data through. So the next thing we need to look at is initial load, where we redeploy the database, redeploy the space, and then watch it load this data from the database. So now we're back at our clean space. We have no processing units deployed. In fact, we're not even going to bother with the mirror because it isn't going to be necessary for the initial load. Let's go ahead and deploy the application itself. We're going to pull this puppy up. I go to processor. And we're going to deploy this. This will go through and, basically repeat our deployment. We're doing it to the UI this time instead. But, we're going to, after it's done, we're going to take a look at the space and make sure it has our 31 items still in it. Okay, so now we have our items. Let's go ahead and close this out and take a look at our space here. So we look at our classes, and you can see here we have our 31 operations again. We saw it clear, start up. There's no load facility here, so we could actually take a look at our data and see everything in here the way that we expect it to be. We see all of our data items in the space. These are the things that we just loaded from the database without any work on our part. It just pulls it in and starts. So that's the initial load and the mirror service examples being shown from Maven with Eclipse and a Derby database on the back end. Hope you've enjoyed it. Thank you very much.